All right, let's talk about area of shapes. So number one, what type of shape is that? That is a rectangle. So when I look at that, I want to look at my star chart and say, what is the formula for area of a rectangle? So what is the area? Okay, the area for a rectangle, A equals BH, B representing base, H representing height. And this one isn't tricking us too much. And one thing to keep in note is that your base and your height will always make a right angle together. Okay, so let's plug in my values. Got 11 times 7 6/100. Solve out the area. Okay, so if I set this up, I can set it up in any order. I'm just going to set it up like this, but we could have done like this. It doesn't matter. So when I do this, I'm going to say 6 times 1 is 6, 6 times 1 is 6, drop a 0, I'm multiplying the tens place, 7 times 1 is 7, 7 times 1 is 7, I add my partial products together, 836. That does not sound reasonable. Oh, I shift my decimal once, so I'm going to shift it back in one time. So I get an area of 83 and 6/10. And I could say centimeters squared, okay? Because if it's squared, it's representing an area. Now, if I look at number two is a triangle. What is the formula for a triangle? Well, when I look at it on my star chart, I have area equals 1/2, and I like to put parentheses around 1/2, base times height. So here we actually have three numbers. Which one of these is not needed for my formula? 9 and 8/10 is not needed because, like I said over here, number one, your height and your base will always make a right angle. And I only need two values for this formula. They gave me 3. You were about to get tricked. So I'm going to label 12 as my base, 4 as my height, and I'm going to plug it in. So I have 1/2 times 12 times 4. Go ahead and solve that out. Okay, so when I follow this, I'm going to follow gems. So I do have grouping, but there's no operation inside of the grouping. I don't have exponents, but I do have multiplication. I have two sets. So I'm going to actually go left to right. And I know that multiplying by 1/2 is the same as dividing by 2. So 12 divided by 2 gives me 6. Bring down my 4. I get an area of 24 feet squared. Yes? All right, let's look at number 3. Let me scoot my... All right, what type of shape is number 3? Number 3 is a trapezoid. What is the formula for area of a trapezoid? If you correctly looked at your star chart, you are going to find that area equals 1/2 parentheses base 1 plus base 2 parentheses times height. Okay, one way to think about my bases is my bases run parallel to each other. So I could say base 1, base 2, and plug those in. And the way to know our height, just like I said in the other two, your height will make a right angle with the base. So my height is going to be 5. Okay, go ahead and solve that out. Now, when we solve it out, I still follow my order of operations, my gems. And so when I look at this, I have groupings. So I'm going to solve and, oh, that's a 13. Bloop. I'm going to solve inside of my groupings first. So I'm going to get 1/2 divided by, or multiplied by 19 times 5. And now I'm going to say 1/2 times 19, but like I said, we also know that that is 19 divided by 2, and it's going to fit in 9 times, give me 18. I have one left, add a decimal, trailing 0. And I'm going to get 9.5. Let's finish off my answer. So I'm going to bring that down. 9.5 multiplied by 5. And when I set something like that up with decimals, I'm going to put my 9.5 in the top because I put the most digits in the top spot. Shift my decimal out. 5 times 5 gets me 25. 5 times 9 is 45 plus 2 is 47. I shifted in once, so I'm going to shift it back in. So I get an area 47 and 5/10 centimeters squared. Okay, let's look at number 4. So number 4 is a circle. What is my formula for area of a circle? I'm going to write it right here. Area of a circle, actually A equals pi r squared. Okay, what value do we plug in for the place of pi? We plug in 3.14. And this R stands for what in that formula? R is going to stand for the radius. Radius being half, the halfway point, half of the diameter. So when I look at this and plug it in, I'm going to rewrite it because I labeled my formula. So when I rewrite this formula, I'm going to say 3.14, and I just put everything in parentheses. And my radius is already actually given to me, 3.5 squared. And I'm squaring that 3.5. Okay, so what we would want to do first is set up our squared, and we know a squared is anything multiplied by itself. Okay, go ahead and solve this out. All right, so when I come back to this problem, I have 5 times, shift out my decimals. I have 5 times 5 equals 25. 5 times 3 is 15 plus 2 is 17. Drop my placeholder, multiplying the tens place. 5 times 3 is 15. 3 times 3 is 9, plus 1 is 10. Boop. So when I shift my decimals back in, I have 3.14 times, and then 3.5 squared gave me 12 and 25 hundredths. Okay, I'm going to switch to a new scratch paper. Actually, we can work it on the paper. So now when I'm looking at this, this is dealing with a lot of decimals. So like I said earlier, I'm going to put the number with the most digits in the top spot. So I'm going to have 12 and 25 hundredths, and I'm going to have 3 and 14 hundredths. Okay, so I'm going to multiply my ones place just like regular. So I'm going to say 5 times 4 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 2 is 8, plus 1 is 9, and 4 times 1 is 4. So if you're checking your partial products with me, that one should line out. And then if I multiply my tens place, my answer starts in the tens place, so I have 1 trailing 0. And I say, let's zoom in. 1 times 5 is 5, 1 times 2 is 2, 1 times 2 is 2, and 1 times 1 is 1. We golden? Okay, now here's something we don't always have to do, but if I'm multiplying my hundreds place, my answer needs to start in the hundreds place value, meaning I'm going to have 2 trailing zeros. Now I'm just going to multiply like regular. 3 times 5 is 15. Boop. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6, and 3 times 1 is 3. So our partial products should match up. Now let's add up my partial products. So I got a 0 all the way down, bringing down a 5. Now I'm going to look. 2 plus 5 is 7, plus 9 is 16. carry my 1. And I have 1 plus 4 is 5. 5 plus 2 is 6. Nope, 7. 4 plus 2 is 6, plus 1 is 7. 7 plus 7 is 14. I have 2 plus 6 to give me 8 and bring down my 3. Now, that reads as 384,650. And I don't think the area of the circle is going to be in the range of 300,000. So I got to remember I shifted 1, 2, 3, 4. So I'm going to start back here and shift my decimal back in 1, 2, 3, 4. So really, my area is going to be 38 and 4,465 thousandths. And I could do inches squared. That was a big one. All right, looking at number 5. 5, read the problems below, sketch a picture, choose a formula, and solve the problems. So 5, a standard size volleyball court has an area of 1,800 square feet. The length of the court is 60 feet. What is the width? Okay, so first off, I'm always going to draw my picture. It's a rectangular volleyball court. So it says the area itself, so it's already giving us the area. And the length is equal to 60, so I'm searching for the width. What would be the formula for a rectangle, area of a rectangle? It's going to be area equals base times height, but I also know that I could also use area equals length times width. So if I plug in what I know, I'm still using my formula. I have 1,800 as the area, 60 as a length, and I'm searching for width. So right now, kind of goes back to our solving for a variable. So solve this problem out to see what the width would be. So I know if 60 times W is multiplying, the inverse of that would be to divide. So I'm going to end with a width of 30. All right, looking at 6. A boy stands on a carousel and rotates around the ride 4 times. If the distance between the boy and the center of the carousel is 6 feet, then how many feet did the boy travel? Okay, so I don't know if you know what a carousel looks like, but it's like the horsey ride where it goes in circles. So if it's going in circles, I'm going to represent this picture with a circle. And it says the boy is at the center, or the center is 6 feet away from the boy. Is 6 feet representing our diameter or our radius? It's representing our radius. So, and actually this time, if you read it, we're going around in the circle. We are not filling up the circle. We're going around. So if I want to know how far the boy went around the circle, am I searching for area or circumference? I'm searching for circumference because think about area fills the inside of something and circumference is like the perimeter of a circle. So I'm actually going to use the formula for circumference of an area of a circle. What is the formula for circumference of a circle? It's going to be C equals pi r. Oh gosh, I mixed that one up. I wrote the one for area. Just scratch it all out. We're going to say C equals 2 pi r. R standing for radius. Okay, so when I plug in my values here, I have C equals 2 times 3 and 1400ths multiplied by the radius of 6. All right, find what the circumference would be. So when I solve this out, 3 and 1400ths times 2 gets me 6 and 2800ths times 6. And if I were to set that up, it's going to get me, so I got 48, 6 times 2 is 12, plus 4, 16, 6 times 6 is 36, plus 1, 37, swoop 1, 2. So the circumference is 37 and 68/100. However, it said the boy rode around that circle 4 different times. So if one time represents 37 and 68/100, how could I find the total amount he traveled around 4 times? I could take this and multiply it by 4. What would my answer be if I multiplied that by 4? So when I solve it out, I'm actually going to get 150 and 72/100. So if the boy rode around the carousel 4 times, he actually traveled around in that circle a total of 150 72/100 feet. This isn't too bad. All right, let's look at this composite figure. 7, a retail shop is replacing their flooring with laminate wood. The floor plan is shown below. Determine the total square feet of the laminate wood needed to complete the job. So first things first, with a composite shape, I need to do what? Because I can't find the area of this weird shape is not on my star chart. So I need to break it up into 2 different shapes. And my eye says to break it up right like this. So I got shape 1 and shape 2. So now it kind of looks like a birthday cake. Do you agree? All right, so both of these are rectangles. What is the formula for area of a rectangle? Okay, so if I'm looking at figure 1, it's area equals BH. And for figure 2, I also have area equals BH. So when I plug in the base of shape 1, and I got the height, so I can just plug those in. There's not really any tricks here. And when I look at shape 2, I'm not going to pay attention to that side. I'm going to pay attention to this base, which gives me 35. And I'm going to pay attention to this height because the base and height make a right angle. All right, solve out the area of those 2 shapes now that we've broken them up. Okay, so when I find 25 times 8, I'm going to get an area of 200. And when I multiply out 25 times 35, I get an area of 875. And when I look at these, so area of shape 1 is 200, area of shape 2 is 875. How could I find what the total area would be for this whole shape? I would add up those two. So I'm going to say 875 plus 200, and that will give us our total area. All right, looking at number 8. Mr. Richardson would like to build a planter surrounded by a brick path, shown in gray. So this is actually my brick path, the outer edge. How many square feet of brick does Mr. Richardson need? Okay, so again, I have 2 figures. So what I want to do is find the area for both rectangles. So I'm going to say that this is shape 1. So the base of shape 1 is what? It's going to be 24, and the height being 12. So when I plug in A equals BH, and I have area equals 24 times 12. Now, if I were to find the area of shape 2, that's going to be my inside measure. So my base is 20. What would be the height of shape 2? It's going to be 8. So when I'm doing composite figures, I always make sure to label and both give them their own workspace. So I'm going to say 20 times 8. Okay, solve for the area of those 2 shapes. All right, so when I come back and look at this, I have shape 1 having an area of 288, and I have shape 2 with an area of 160. Now, when I look at this, he wants a brick, he wants to know how many square feet this brick path is going to be. Is he filling this whole entire rectangle? He's not. So what could I do if I only want to fill the outside and not fill in this area? What could I do with these two numbers? I could subtract them because he doesn't want to fill in the whole thing. He wants to take this amount and subtract it by the inside area, giving him how much? He's going to need 128 square feet. All right, let's look at 9. And actually, 9 didn't copy well. So if I filled in what should be copied, like this. Okay, let's look. The figure below is composed of 9 congruent squares. That word right there is a big word. What does the word congruent mean? It means same size, same shape. What is the area of the shaded portion? So it's saying if all of these squares put together equal 12, and each square is the same size, same shape, how can I figure out what one square would be? Well, my brain says that if I have 3 squares, I could divide 12 by 3 to give me 4. So that means each square is 4 by 4. Okay, so this one square has a side length of 4 and then a width of 4. So how could I find the area of just one square? I could multiply 4 by 4. And square, we use A equals BH. So I'm going to have area equals 4 times 4, giving me what? An area of 16. Well, 16 represents just one singular square. How could I find the total area if I wanted to find the area of 5 squares? I could take the 16 and multiply it by 1, 2, 3, 4, 5. Now, if I did that, what is the total area of the shaded portion? It's going to map out to be 80 inches. Oh my goodness, 80 inches squared, not to the 20th. All right, last one, let's go. Okay, basketball court is being painted. The entire section below will be painted blue. Determine how many square feet of paint will be used. All right, my brain sees 2 shapes put together. That means it's a composite figure, and actually, they've already cut it for you. So I'm going to say that this is shape 1, and this is shape 2. Now when I look at this, shape 1 is a rectangle. What is the formula for area of a rectangle? It's going to be A equals BH. And if I fill in my values, I have a base of 15 and a height of 8. What would that give me for the area of that rectangle? It's going to give me a total area of 120, yes? Okay, now let's look at figure 2. What is figure 2? It is half of a circle. Okay, so if I'm finding area of a circle, I'm not finding the area of a full circle, what's the formula going to be if I'm finding the area of half of a circle? It's actually going to be A equals 1/2, right, pi r squared. Now when I look at this, 8 feet represents the height of the whole side. Now 8 representing the diameter or the radius here? 8 is actually representing the diameter because it's the full length. If I wanted to just take half to find the radius, then I would have a radius of what? I'm going to have a radius of 4. So when I plug in my values, I have 1/2 times 3.14 times my radius of 4 squared, yes? All right, go ahead and solve that out. So when I finish, I go in I actually would solve my exponents first. Exponents would come before multiplication. So I'm going to bring down 16 because 4 squared represents 4 times 4. And then I have times 3 and 1400ths times 1/2. Okay, so now if I divide 3.14 by 2, I get 1 and 5700ths times 16. And when I get 1 and times 16, let's work it out. So let me take my camera down. 7 times 6 is 42. 5 times 6 is 30 plus 4 is 34. 6 times 1 is 6 plus 3 is 9. Add a 0, my placeholder. 1 times 7 is 7. 5 times 1 is 5. And 1 times 1 is 1. 11. 9 plus 5 is 14. Plus 1 is 15. And when I shift my decimal in twice, I get 25 and 1200ths. Do you agree? So now I'm going to take my 25 and 1200ths for, this is the area of figure 2. And if I have the area of figure 1, what am I going to do with those two areas? I'm going to combine them. So I'm going to set up 120 plus 25 and 1200ths, giving me a final answer of, solve it out,